Nowadays, people cannot live without social network. We use Facebook to post news, photos, Google Hangout to make video calls. However, when disaster happens, electricity and cellular network are down and we cannot use these tools anymore. What can we do? Today, my teammates Chen Ran, Zach, Xiaotao, Wei, and me Fei will introduce the project we built within the last 3 months. It is called Survivable Social Network on a Chip. As the name shows, it helps people build a survivable social network and allows us to communicate on an emergency. First, we will give you the vision of the project. After that, with examples, we will walk you through the software architecture and functionalities we applied. And then we will talk about the key practice we adopted and the lesson we learned from the project. There are 3 main users: citizen, coordinator, and an administrator. For citizens, they can share their emergency status, post information, chat, or make phone calls to others. For coordinators, they can post announcements and analyze the social network. For administrators, they can admin user profile and content. With all the function above, we aim to provide people a stable and efficient way to communicate in disaster situation.
This is Wei. I'm going to talk about platform, framework, and technology that we have used in our software architecture. This picture shows the deployment diagram. We divided the software architecture into 2 parts, backend and frontend. For frontend, our application runs in web browser. For backend, we adopted 2 HTTP servers. One is Node.js and the other is Jetty. First, Node.js handles HTTP requests from web browser. After that, it may request data through a RESTful API from the Jetty server. Now, let's talk about the platform. For hardware, we use the BigBone Black. It's a no-cost, community-supported development platform for developers and hobbies. It has an AM335X 1 GHz ARM processor, 512 MB RAM, and 4 GB flash storage. For operating system, we use Debian OS. For web browser, we implemented responsive web design using Bootstrap, which allows users to access our web application through multiple devices such as smartphone, tablet, or PC. Now, let's move to framework. For frontend, we used the template language Jade for frontend development. We adopted Express for Node.js server. For backend, we choose Jetty for RESTful API, H2 for backend database. Here are the technologies we adopted for our powerful system. For example, we have used Git for subversion management. We put both frontend and backend code on GitHub and manage them cooperatively. Our Jetty server is deployed on Heroku, and we implement auto-deployment so that the server will be restarted after every commit. Continuous integration is also supported based on Travis and Shippable. Besides that, to facilitate development, we also implemented static analysis to find bugs and improve code quality. For front-end development, we use WebSocket and Ajax for communication. We also adopted cutting-edge technology like WebRTC to implement point-to-point real-time communication.
Hi, I'm Chen Gong, and I'll talk about creative functionality. First, message alerts. To keep users in touch with the latest message, we applied HTML5 WebSocket technology. In this case, when user A sends a hello message to user B, our system will pop up a little green screen that notifies user B the coming message. Second, self-adaptive UI design. In order to give users a consistent user experience, we applied Bootstrap technology in UI development. In this case, no matter what mobile device or laptops the user uses, our UI can adjust the display based on their screen size accordingly. Third, customize the navigation bar. As we mentioned before, we have 3 main users, which are citizen, administrator, and monitor. Each of them have different privilege. In this case, we customized the navigation bar so that different types of users can only select the options open to them. For example, only administrator can admin user profiles. The fourth creative functionality is audio call and video call, which will be implemented in iteration 5. From the photos, user can choose one of the online users and choose the type: text chat, audio call, or video call. The photo in the middle is our audio call design, and the right photo is our video call design. Both of them are just photo types, and we'll implement them very soon. And the technology and skills we'll use is WebRTC. WebRTC has video engine and voice engine, and some APIs such as Network Stream API, RTC peer connection, peer-to-peer data API, and so on, can help us to implement this functionality.
Hello, I'm Xiaotao Jin. I will introduce software engineering practices that we applied for the project. For the run method, we combine Kanban and Scrum. This hybrid method helped us increase the visibility and adaptability and reduce the risks of our project. For each iteration, we follow the method from values to principles to practices. I will highlight the 4 aspects that worked well for our team. First, for team collaboration, we have A working as a project manager, being responsible for project management and progress control. Zach and me working for backend, while Chen and Wei working for frontend. This did not mean that each of us only took care of his or her own parts. Instead, if some of us met problems, we would be backup for the person. Second, to facilitate the communication within the team, we have stand-up meeting 4 times a week. This allowed us to exchange information effectively and efficiently. Third, to keep the work on schedule, we tracked our task list using Trello. This improved our work efficiency by visualizing the project plan. We had a clear view about which parts had to be done, which parts needed to be improved. It helped us deliver work on schedule. Last, we adopted another excellent Scrum practice, which was sprint review. After each sprint, our team would gather together and review the last sprint. We would make summary by identifying what we did good and what we did bad. In this case, we kept making our mistakes and becoming more effective and productive. To ensure the quality of our code, our team also put test-driven development in practice. We wrote following tests, made tests pass, refactored source code, and went on. If you ask what painful thing that you have experienced in this project, we would say that code review must be one of them. Every time you wanted to find out bugs, it seemed so tiring and difficult. We wish we could be Superman, Superwoman when we were conducting code review. Maybe it could be a little bit easier, just like this one. She must have found 100 bugs. Do you know what's pair programming? No, it's not this one, it's this one. When we are conducting pair programming in our team, what impressed the most is that it facilitated quality standards, problem solving, and troubleshooting. When one person is coding, he may not be aware of some small bugs or mistakes that he makes, but with pair programming, the other teammate would figure out this kind of mistakes and solve them immediately. So the overall quality of the project is enhanced dramatically. Another unique practice of our team is that we use hierarchy to conduct continuous built-in tests. With this tool, we were able to automate compilation and test every time we pushed code on GitHub. In order to determine the value of each task, our team used the plan poker to facilitate our decision. We found it very useful thing that during planning poker process, teammates would discuss intensively their opinion on use cases. More discussion on use cases more detailed information we found and the deeper we understood them. Good understanding of use cases helped us greatly in the development phase so that we could complete the requirements directly and correctly.
Hi, I'm Zach. Let's talk about what we have learned from this project. Starting from design and analysis, through development, testing, and finally to deployment. This project focuses on learning by doing, and we have utilized lots of tools to assist us finish our project. These tools not only make the whole process more efficient and organized, but also give us a great opportunity to try new things and get our hands dirty. One important factor of the success in our project is that we have effective teamwork with thoughtful planning and organization. Abilities and experiences vary among our team members, so the project work allocation was based on who can best perform each task, which means everyone did what he is best at, hence our team can function at the highest possible level. Another thing we work well is pair programming. In each iteration, we partition job into two parts, front-end and back-end. Each part is responsible by two persons to practice pair programming. The benefit of pair programming is that our code quality increases since one can double-check his partner's code to reduce the risk of error. In addition, coordination between front-end and back-end is significantly reduced because just one member is needed to be present while synchronizing within our team. Good project control also leads to the successful performance of our project. We managed and monitored our project through Trello, which gave us a comprehensive visualization of the project and helped us keep track of every feature. Thanks to our team's collaborative efforts, we delivered almost every feature on time in each iteration. So, what we did not work well is the estimation of difficulty and effort of features. Since we distributed the workload based on the difficulty and effort of each feature, imprecise estimation will lead to the unbalanced job assignment. This phenomenon is especially significant for our front-end system. Some features are quite complex than we have expected in the planning phase. Hence, the front-end developer put lots of effort and time in developing the feature beyond our expectation. One possible solution to improve this is to consult front-end experts to obtain their suggestions and some more technical information for the estimation. That's all for our presentation. Thank you.